aldehydes, ketones, and carboxylic acid. Now, before starting this chapter, I would like to first of all make an announcement. Okay. And the announcement it is regarding there were a few complaints from the parents that the students are very negligent when they attend the classes. Anna. So now I'm requesting all of you guys that you should attend all the classes with your cameras on. Okay. You won't be attending any classes with your cameras off. There will be focus mode. So your whatever video is being shared now, if you turn your camera on, so the recording will not be recording your part. It will be only recording the screen. Okay. So focus mode is on. Those who can turn the cameras on, please turn it on, guys. Guys, please see, it's not a request. Okay, you have to turn your camera on. All of you guys. Okay, thank you, Rajita. Waiting for Sia, Deborah. Guys, am I not audible? What happened? Yes, Fia, Deborah. Okay, Fia wants to turn it off from the next class. Okay, fine, Fia. I'm trusting you guys. Okay. What about you, Deborah? That's fine. You can, I mean, see, even my camera has some problem. That is why you can't see that any camera options in my, you see my name, you can see some mic option, but you won't see camera options. Okay. So it's only because I have also some problems, but I can see that there are camera options available for you now. So you can turn it on. Even my camera is moving. That is why generally right now it is not fine. It's on, turn on. Okay. What about others? Jaldi, hai na? Safia, what about you? Can turn the cameras. You have to turn your camera on. No? We will be continuing classes only. All of you guys start the camera on. Yes, Safia, am I audible?
Yes, sir.
You want a minute to turn the camera on? You can turn it on now. Yes, Safia. Also, Majid. Yes, Majid, tell me. Majid, am I audible? Next class. Okay, fine. Next class is fine. Okay, thank you, Sophia. Just give me a second. 264492592 5923.
Sir, in chemical kinetics, only that two lessons are left.
Yeah, only those two. Everything else I have done in the extra classes. Okay, so you do those two classes, that will be enough. But again, I would again say that start with the NCERT exercises. Okay, if you don't do the exercises, it will be of no use. Each and every student, they attend the lectures, but why some score high and some score low? It is only because of the self-study hours, you know. So you do the questions of NCERT, that will be more beneficial. Fine. If you are going to cover the width and not the depth, it will be not useful. Okay. Now, starting with aldehyde, ketones, and carboxylic acid. First of all, let us see the structures or the shapes of the groups that we are going to study in this particular lecture. So aldehyde, it has a structure which is C double bond O. It will be further connected with hydrogen. Achha, I just want to confirm a few things. Safia and Rajita, you guys can see each other's videos. Yes, Rajita, can you see Safia's video?
I can see the video.
No, no. Safia, you also can't see Rajita's, right?
No, sir.
You can only see mine, right?
Yes, sir.
I just wanted to check how good is the focus mode. Okay. So this is the structure of aldehyde. This is the complete structure. You will be mostly looking it as CHO. This is aldehyde. Then we have C double bond O. Achha, when I have not shown what is attached here, that means there are some carbon atoms. You know? Similarly, in ketone, there will be carbon atom on both the side of C double bond O. And this is represented as CO. Then this is known as ketone. Then we have carboxylic acid. Which will be C double bond O and OH. This will be represented as C double bond C double O H. This is carboxylic acid. Carboxylic acid. So these are the primary functional group that we have to see. Then there will be some functional group that we are going to see in this category. One of them is ester that we are going to see often, C double bond O, and you will have OR dash or OR, you can see. So if you have fragment like this, then this is the ester functional group, or you can see it in a condensed form, that is COOR. This is ester. Next is next. A second. Next, we are going to have ester. After ester, you will be having anhydride, right? That is C double bond O. Then you will have oxygen here like this. Then C double bond O and some R group here. So these two carbons will be attached to some RR groups. How are we going to write this? So let us suppose there is an R group here and here. So condensed formula will be R, C double bond O is written as CO. This is twice, and then we have one oxygen. So here we have RC double bond O. So RCO, another RCO. That is why we have two RCO and one oxygen. This is known as anhydride. So these are the major functional group that we are going to see in this particular chapter, aldehyde, ketones, and carboxylic acid. But primarily we will be focusing on aldehyde, ketone, carboxylic acid, meaning method of preparation of aldehyde, method of preparation of ketone, method of preparation of carboxylic acid, and their respective chemical properties. Okay. Now, in between, you will be seeing esters, you will be seeing anhydrides also. Now, before moving to the general idea of method of preparation and chemical properties, we are going to look at nomenclature. We are going to look at nomenclature. Now, in nomenclature, I will not be discussing the IUPAC nomenclature. Rather, I will be discussing the common names. Common names will be used the common names which are going to be used, and you will not be familiar with these common names. And you must have some kind of confusion regarding them from the 11th standard, or if this chapter is done in your school, then from the school. So what happened to Safia? So Safia got disconnected. Okay. See you guys. So in nomenclature, first we are going to look at the common name, number one. A part is common name. And this will be a bit new things for you. So in common name, I will first of all discuss a concept that is known as acid. Please see here, don't write anything. Rajita, please don't write anything. See here, guys. ACET. ACET. So ACET means we have CH3, C double bond O. And depending on what is attached to C double bond O, the complete name is written. For example, if you see acid, and after acid they have written aldehyde. So the molecule will be CH3, C double bond O. What should I attach on carbon to make it aldehyde? Tell me, guys. What should I attach on carbon to make it aldehyde?
CH.
No, only hydrogen. See. All of you got this? Yes or no? Please tell me. हाँ बताएं. Fia, Rajita, Razin, Safia.
Yes,
what we are going, all of you got this now? What
Yes,
happened, Safia? Okay. So here we are going to add hydrogen and we will get aldehyde. Similarly, if there is a name which is acetone, acetone, we know that one is used for ketones. So CH3, C double bond O will be as it is for acid. Now, what is the smallest thing that we can add to make it a ketone? I can add many things to make it a ketone. Now, I can add CH2, CH3. Yeah, that means C2H5. I can add CH2, 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 CH3. That will be also ketone because we are having alkyl groups on the both sides. But what is the smallest fragment that I have to add? If you add CH3, this will become what? A ketone. So smallest thing that you have to add is what? CH3. So this is acetone. This is acetone. Similarly, you will be seeing acetic acid. Acetic acid. What is acid? Acid is CH3, C double bond O. Now, acid means carboxylic acid. What should I add to make it carboxylic acid? Please tell me, guys. What should I add to make it carboxylic acid on carbon? What should I add? Guys, tell me. What should I add on carbon to make it carboxylic acid?
OH.
Very good. Correct, Razin. We have to add OH. It will be now carboxylic acid. Okay. So I hope you can see that main funda, the main difficulty that students have is now to understand these names is in acetaldehyde, it is 2 carbon. They start thinking in this way, and obviously, I mean, you have to make some kind of logic. Now you have to make some kind of logic with whatever you have been given. So what the student is first start and how they understand. Okay, acetaldehyde 2 carbons. Then they see acetic acid. Okay, 2 carbons. But when they come to acetone, we have 3 carbons. Then they start abusing chemistry. पूरा exception है यार chemistry में, कहीं पे कुछ भी होते रहता है. But that is not because of chemistry. That is because of your understanding. You have taken the wrong pattern. What is acid? Acid is CH3 C double bond O. Now let's see another case. We have seen acetic acid also. Then we will have acetophenol. Now, when we have written phen, PHEN, that represents benzene ring. When we have written one, that represents what? A ketone. Now, this they have already given all the structures. Acid means what? CH3, C double bond O. So, what is this carbon further attached to? It is making benzene and it is attached with phen. What is phen? Phen is the old name of benzene ring. So, we will attach benzene here. This is acetophenol. All of you understood all of these 4? Yes or no? Please tell me, guys. ये 4 समझ में आया सबको? ठीक है, ध्यान रखिएगा प्लीज. ओके, कैन नॉट फॉरगेट दीज. Acetaldehyde, acetone, acetic acid, and acetophenol. These are very important. And write this down. Raise your hand once you're done. What happened to your video, Safia? अच्छा, ठीक ठीक, थैंक यू. ये थोड़ा सा ना, मतलब हम भी आप लोगों को बोलेंगे दैट प्लीज कीप योर वीडियोस ऑन. उसका दूसरा रीजन ये है, वो हम बोल रहे हैं, लर्नियो बोल रहा है, उसको तो आप छोड़ दीजिए. कुछ बच्चों की आदत होती है थोड़ा सा डिस्ट्रैक्ट हो जाते हैं ना, जैसे कोई आपका छोटा कजन आया है ना, कोई मेहमान आए हुए हैं, तो आप थोड़ा डिस्ट्रैक्ट हो सकते हैं. उन डिस्ट्रैक्शन से बचने के लिए आप कैमरा ऑन कर दीजिए. ठीक है, पढ़ाई पे थोड़ा फोकस करना स्टार्ट करेंगे ना. अब सितंबर आ गया है, ज्यादा टाइम तो है नहीं. अब आप दूसरी चीजों को इग्नोर करना स्टार्ट कीजिए, है ना. कोई आएगा बोलेगा अरे ठीक है ना, क्लास कर लो यहीं पे ऐसे ही. कुछ रिश्तेदार भी बोल देते हैं ना इस तरह से, ऑनलाइन ही तो है, कहीं भी बैठे कर लो. वो चीज आपने अब नहीं करनी है. आपको आराम से बिल्कुल अपने टेबल पे, चेयर पे बैठना है और प्रॉपरली क्लास करना. अब बोलेगा नहीं नहीं मेरा कैमरा ऑन होता है, मैं ऐसे कहीं पे नहीं बैठ सकता. ठीक है, एक रीजन वो लेके चलिए कि कैमरा क्यों ऑन कर. पढ़ाई तो करनी ही है, पढ़ाई तो करने आए ना. छोटा सा बैच है आप लोग का 8 स्टूडेंट को, किस लिए? ताकि अच्छे से पढ़ाई कर पाए. चलिए, लेट मी नो वंस यू आर डन गाइस. रेज योर हैंड वंस यू आर डन. You can raise your hand if you are on laptop by using Alt Y, I guess. Yeah, Alt Y. If you press Alt Y in your keyboard, Aliza, Deborah, Fia, done. Raise your hand quickly, guys. Raise your hand quickly. Waiting for Fia and Majid. Waiting for Fia and Majid. Okay, everyone is done. Now, the next concept is of form. FORM. The B concept is for form. So, what is form? FORM. And form. Form means hydrogen connected to carbon, doubly bonded with oxygen, and then further something is attached. Okay. So from this, obviously you can see that because one carbon is already attached to hydrogen and I can attach something only at one side. That means here we can never have a ketonic form, because what is ketone? Both sides of carbon there should be alkyl group, but on one side we have fixed that there will be hydrogen. That is why In form, we will not have any ketonic form. We can have only two forms, that is either formaldehyde or what else we can have? We can have formic acid. Now, what is the smallest fragment? H, C double bond O will be there. I have to add H here to get at what? Aldehyde. Smallest fragment is H now. If I add H, it will be CHO. We have got what? We have got a formaldehyde. For formic acid, H, C double bond O is present because of form. For OIC, I mean for the ic acid, I will add OH. We have got formic acid. So this is HCHO and this is HCOOH. Please write this down. Let me know once you're done. Once you're done, you'll write next, that is, in common name itself, you will write use of alpha, beta, and gamma. Alpha, beta, and gamma for substituent, for position of substituent. For position of substituent. Okay. Yeah, I hope everyone is done. Let me know if you're not done. Please see here, guys. Use of alpha, beta, and gamma for position of. Here we are going to understand.
Sir, can you scroll up, sir?
Yeah, sure, no problem.
Yes, sir, done.
एक तो आपने हाथ रेज किया हुआ है, किया, हमको लगा आपका तो हो ही गया होगा. चलिए ठीक है, देखिए. See here, guys, use of alpha, beta, and gamma for position of substituent. Please don't write anything. अभी आप पेन को छोड़ दीजिए बिल्कुल और ध्यान से देखिए. Here we are going to understand two different things: how to use alpha, beta, and gamma. Also, what are some common names for the chain length? For example, if I have 4 carbon atoms, 1, 2, 3, 4 carbon atoms, and I have a CHO group here. I have what? I have a CHO group here. Then this 4 carbon, this will be known as butyraldehyde. Butyraldehyde. Okay. I hope it is very clear, na? Butyr. अच्छा, एक और चीज हम आपको थोड़ा बता देते हैं. You will not be given structure and then you will not be given the name. You will not be given the structure and ask the name. You will never be asked the name. You will be given the name and you have to make sense of the structure. They will never ask you what is the common name of HCHO, but they will be using words like when formaldehyde reacts with. So as soon as they say when formaldehyde reacts with, you should know what is the structure of formaldehyde. They will say, how will you convert acetone to, let us suppose, propane 2-ol. So you should know what is acetone. Then only you can do the further question. So whatever I am going to give you, it will never be asked in the nomenclature part. It will be asked in the reaction part itself. They will ask you, they will give you acetone, ethanol, acetone, formaldehyde, acetaldehyde, and they will give you acetic acid. Arrange them in the increasing order of boiling point. So how you should know what is acetone, then only you can go to the further question, right? If you don't know, then how will you go? So all of these things that I'm going to teach, they are never going to give you the structure, then ask the name of the structure. Always you will be given the name and there will be some use of that name. Okay? You will always have to go from the name to the structure. So when they have given butyraldehyde, you can easily see that here you are having but, that means 4 carbon atoms, and aldehyde. Now let us suppose that we have a beta carbon. Here we have, let us suppose, bromine. Now this is our functional group. This is the carbon that is attached directly to the functional group. So we will call this alpha carbon. This carbon is the second carbon. We will call this beta carbon. And let me make this carbon will be known as gamma carbon. The next carbon will be known as the gamma carbon. Okay. So right now, this name will be changed to, from butyraldehyde, it will be changed to beta bromo. We'll be writing what? Beta bromo. Beta bromo butyraldehyde. Is this clear, guys? Yes or no? Please tell me. Hanji, Pia, you have some doubt?
Sir, can you explain that alpha, beta, gamma again?
Yeah, fine. You identify, first of all, what you will identify? You will identify the functional group. So CHO is the functional group. Carbon directly attached on the functional group will be alpha. Carbon directly attached to the alpha carbon will be beta carbon. Carbon directly attached to the beta carbon will be gamma carbon. For example, here we have COOH. Then in this case, this will be your, this is the functional group. So ignore the functional group. Directly attached alpha. This will be next with beta, then gamma. Got it? Yes or no? Pia? Anji,
Yes,
Pia
sir.
got this? Yes or no?
Yes, sir, understood.
Okay, COH, and here let us suppose we have chlorine group. So we will write the name as alpha chloro. 4 carbon atoms, so it will be butyl aldehyde. Razin, you understood this? I did not see your message. Yes, Razin? So you got it now. Okay. Now, similarly, if for 4 carbon atoms we have butyraldehyde, then for 3 carbon atoms, let's suppose we have 1, 2, 3 carbon atoms, CHO like this. And here we have what? Chlorine group, let us suppose. So this will be known as alpha chloro. Now, this is 3 carbon atoms. That is why it is known as propion aldehyde. Propion aldehyde. Again, as I said, they will give you propion aldehyde. You have to make the structure. So from prop, you can easily understand that we are having how many carbons? We are having only 3 carbons. From prop, you will understand it. Okay, so you don't have to worry about the namings too much. They will give you the name. You have to make out what the structure is. Similarly, for if you have 3 carbon atoms with COOH, this is going to be propionic acid. Propionic acid. Oh, yes, yes, yes. Thank you very much. This will be butyric acid. My bad. Guys, please see. 1, 2, 3, 4 carbon atoms. It will be alpha chloro butyric acid. ठीक है. Thank you, Razin. बाकी लोगों ने तो ध्यान ही नहीं दिया लगता है. Guys, please see this one. Those who have written, I wrote it as butyraldehyde. It will be butyric acid. ठीक है. Write this down. Let me know once you're done. Anyone still writing? Please let me know. Anyone still writing? Okay, no one is writing, I hope. Please. Next is Razin. Please turn your mic on when I ask this, okay? Don't write in chat these things. Turn your mic on if you are asking me to wait. Done everyone? Razin हो गया आपका? Razin done?
No, sir, I need to write the last.
Those who are done, they will write naming of ketones using alkyl group. ठीक है? Here guys, you will be given names such as I said, you will be given names, you have to make out the structure. Okay, so they have given you the name dimethyl ketone. Dimethyl ketone. So as soon as they have, please listen, don't write now. As soon as they have given you ketone, you will write C double bond O. Some group attached here, some group will be attached there. Now what they have given dimethyl. So there are two methyl groups. So one CH3 here, another CH3 here. Got this? Dimethyl. So one methyl group this side, one methyl group will be that side. For example, if they have given you something like this, ethyl, methyl, ketone. You will make the ketone. What is ketone? C double bond O. Make the C double bond O. There will be two groups attached here and here. One of the group will be ethyl. The other group will be methyl. What is ethyl? Ethyl is C2H5. What is methyl? It will be CH3. You can write C2H5 here. You can write the CH3 here also. There is no issue in that. Okay. Let us suppose they have given you diethyl ether. Then you will write C double bond O like this. Both the groups will be C2H5 and here also C2H5. All of you understood this? Please tell me yes or no. Anji. All of you got this? Yes. Safia, Rajita, Deborah. माजिद आपको समझ में आ रहा है? शांत है बिल्कुल आप माजिद?
हाँ सर।
ओके। ठीक है, अब एक लास्ट स्ट्रक्चर है, इसको बिल्कुल ध्यान से देखिएगा और इसको याद कर लेने की कोशिश कीजिए। वन स्ट्रक्चर दैट इज डाइटर्ट ब्यूटाइल ईथर। चलो माय बैड गाइस, ये तो हमने ईथर लिख दिया है, यहाँ पे कीटोन होगा, इसको ठीक कर लीजिए प्लीज। डाइथाइल कीटोन, ठीक है, इट विल बी डाइथाइल कीटोन नॉट ईथर। ईथर नहीं पढ़ा रहे, ऊपर क्या लिखा था हमने? कीटोन ना। हाँ ठीक है, लास्ट लिखिएगा, इट्स वेरी इंपॉर्टेंट। डाइटर्ट ब्यूटाइल कीटोन, डाइटर्ट ब्यूटाइल ketone. So सबसे पहले you will obviously have C double bond O. Next, there will be two groups attached here and here. What are those two groups? Those two groups are tertiary butyl group. Tertiary butyl groups. Okay. So what is tertiary butyl? Butyl as well. Butyl. So what is tertiary butyl group? There will be 4 carbon atoms, and the connectivity will be from the tertiary carbon. So CH3. CH3, CH3. If you look at this particular fragment here, this is how many carbons? 4 carbon atoms. That is by bute. Why it is tertiary? Because the connection is from the 3-degree carbon. This is the tertiary carbon, right? The connection is from the 3-degree carbon. That is why it is third butyl. So here also you write the same thing. Carbon which is further connected with CH3, CH3, and CH3. This is very important. You have to know this structure. Okay, there are certain Y type of questions regarding this ditert butyl ketone. There are a few method of preparation which cannot prepare ditert butyl ketone, and they will ask you why we cannot use this method for the preparation of ditert butyl ketone. Then you will have to answer. ठीक है, चलिए नेक्स्ट मिसलेनियस थोड़ा लिख लीजिए। So in miscellaneous, first of all, you will have CHO, benzene ring directly attached with CHO. This is benzaldehyde. Benzene ring directly attached with C double bond O, CH3. अगर ये याद हो, CH3 C double bond O, acid, and this will be phenol, right? So this will be acetophenol. Then you have here COOH. This will be benzoic acid. ठीक है, ये मिसलेनियस में कुछ आपको याद रहना चाहिए. Then there are a few that we have to understand regarding the IUPAC nomenclature. ठीक है, so I will not be doing the generic IUPAC nomenclature as we have done this. Okay, those who have problem in naming of the structures, na IUPAC naming of the structure, please WhatsApp me. All of you must have my WhatsApp number. If you don't have WhatsApp number, please write this down. Okay, please write this down. Screenshot this slide. +95 +917530. Please WhatsApp me on my on this number. I will send you a playlist which will be helpful for you for what? For the IUPAC nomenclature. Anyone is having problems in IUPAC nomenclature, please message me. I will send you the playlist. Watch from there. In this particular topic of IUPAC nomenclature, we will be not discussing the generic IUPAC nomenclature, but of a few special molecules. For example, I have a 3-carbon atom molecule, and each of the carbon atom is having a CH. This is also CHO. Here also we have a CHO, and here also we have a CHO. Now, when we have this type of fragment, it will be very difficult us to name, because we cannot leave. If let us suppose I am taking this particular fragment as my main chain, then why I am ignoring the CHO? Are these CHO, I mean, we can have 2 CHOs in a main chain. Are these CHO more important than the other one? Obviously no. So to give the CHOs equal treatment, what do? We write the name as following. We'll see that we have how many carbon atoms? We have 3 carbon atoms. So 3 carbon atoms means propane. We'll write propane, and 1, 2, 3, not al. If you remember aldehyde, what is the suffix that we use for aldehyde? Al. But Al is used if the carbon is counted in the parent chain. Right now we have not counted the carbon of aldehyde. I've just counted 1, 2, 3 of the carbon chain. So I will write carbaldehyde. Is this clear? Yes or no? Please tell me, guys. उसी तरह से अगर मान लीजिए आपके पास if you had, yes ना, clear है सबको? If you got COH and COH, अच्छा एक सेकंड गाइस, ये 1 2 3 के बाद ट्राई कार्बोल्डिहाइड होगा. माय बैड, थोड़ा सा ना आप लोग मेरा स्लाइड कंप्लीट हो जाने दीजिए ना, तो ना आप लोग को मिस्टेक्स क्लियर करने पड़ेंगे. ठीक है, इट विल बी 1, 2, 3 tricarbaldehyde. Similarly, if you have something like this, it will be propane. Pia, do you have some doubt?
No, sir, I think it's okay.
It's okay ना, तो आप हाथ अपना थोड़ा डाउन कर लें. Propane 1, 2, 3 tricarboxylic acid.
Sir,
Okay.
why it is carbaldehyde?
It is carbaldehyde because, for example, if you have something like this and CHO, what do we write? 1, 2, 3, 4 carbon atoms. So we are counting the carbon atom in that main chain. That is why we write butane 1-al. So we have counted the carbon atom in the chain. That is why we are not writing carbaldehyde. But in this case, we have only counted 1, 2, 3 carbon atoms. We have not counted the carbons of the CHOs. That is why we are writing tricarbaldehyde. Got it?
Yes, sir.
So this carb is representing the carbon. Here also, if you see, for carboxylic acid, we generally write oic acid. Why? Because we count the carbon atoms in the main chain. When we are not counting, then we will write carboxylic acid. I hope it is clear, right? Yes or no? Rajita, Safia, clear hai?
Yes, sir.
Okay. उसी तरह से देखिए, there is a structure. I think this question is there in NCERT. How will you name this particular compound? So now this CHO, it is not part of any main chain. And if you are going to take the main chain as this ring, obviously you can see that CHO is not inside. I mean, it is connected to that ring, but it is not part of that ring. If you are counting the ring, then we are not counting the aldehyde carbon. So how will we name this? We will name this as we have named the previous cases, cyclopentane carbaldehyde. You can see, you can write it cyclopentane carbaldehyde, or you can also write it like this, cyclopentyl carbaldehyde. Both of these are fine. Okay, cyclopentyl carbaldehyde or cyclopentane carbaldehyde.
Sir, so for all the aldehyde compounds, we'll write like carbaldehyde only.
No. नहीं ना. For example, if you have simple, see, अभी तो लिखा ना butane 1 हाँ, yeah.
Yes,
I wrote
sir.
this na butane 1. So when the aldehydic carbon is counted in the main chain, you will write Al. If it is not counted, then you will write carbaldehyde. Okay. Generally, देखिए हम एक बात बता रहे हैं. See, yeah. If there is a question of carbaldehyde, it will be one of these questions. Nothing extra. इसके आगे वो पूछेंगे. They will not ask you. If you will get a question,
Okay.
I will say like 90% chances that you will get this question. Not also the previous cases. Okay. Otherwise, it is always Al. Okay. The generic case. These are specific cases. Okay. Now moving on, we'll move on to the method of preparation. Okay. Please see here. Method of preparation of aldehydes and ketones. Method of preparation of aldehyde and ketones. Now, in method of preparation of aldehyde and ketone, we will be learning about a few methods of preparation. First, we will learn about method of preparation of aldehydes only. Secondly, we will learn about the method of preparation of ketones only. Lastly, we will look at the method of preparation of aldehyde and ketones both. That means there are some chemical species. There are some chemical species which will give you only aldehydes. They will never give you ketones. There are some chemical species which will give you only ketone. They will never give you aldehyde. And there are some chemical species which are going to give you aldehydes as well as they can give you ketones. A very good example of this particular case is, if you remember from alcohol chapter, if I use 1 degree alcohol and oxidize it, I will be getting a aldehyde. If I take a 2 degree alcohol and I oxidize it, then I will be getting a ketone. So from alcohols, we can make aldehyde as well as ketone. Okay. So I'm giving this you just an example because we have already done alcohol, phenols, and ethers chapter. Okay. So first of all, we look at the method of preparation of aldehydes only, then ketones only, and then aldehyde and ketones. Now, write first of all MOP of aldehydes only. Right here, MOP of aldehydes only. Part A. Now, in aldehyde only, you will write the first reaction, that is Rosenmund reduction. As soon as you see a name reaction, please understand it is already important. Rosenmund, as soon as you got the name, it is important. It became important as soon as it got its name. If it has a name, it is important. Okay. Rosenmund reduction. What is here? So in Rosenmund reduction, we will start with acyl chlorine. R C double bond O Cl. Obviously, it is reduction. So from reduction, you should remember that we will be adding H2. Addition of hydrogen is reduction, or removal of oxygen is reduction. So here what we are doing, we are adding hydrogen. Achha. What we are using is, we are using PDBaSO4 as a catalyst. What will happen? Chlorine will be replaced by hydrogen. C double bond O as it is, chlorine will be replaced by hydrogen. So we will start from acid chloride. We will get aldehyde. So this works for both the things, aliphatic as well as aromatic. That means you can have something like this, COCl the presence of H2 PD over BaSO4, you will get CHO. Okay. You can also have benzene ring COCl. Okay. You will write the statement also, because sometimes it will be difficult for you to understand when they give you statement. Please write acid chloride is converted to aldehyde, is converted to aldehyde by catalytic hydrogenation in presence of PD over BaSO4. Palladium over barium sulfur. Right, the second reaction is again a name reaction, Stephen's reaction. Or Stephen reduction. It is also known as Stephen reduction. Now, in this, what is going to happen? You will start with nitrile R C triply bonded with nitrogen. This is nitrile. Then you will react nitrile in the presence of stannous chloride. What is stannous chloride? It is SnCl2 in the presence of HCl. Here you will get R CH doubly bonded with NH. That means both carbon and nitrogen are getting, just a second here. Both carbon and nitrogen are getting hydrogens. After this, you will just add H plus in the presence of water. You will get RCHO aldehyde. Yeah, please check this. Let me know once if you're done. Okay, so in Stephen reduction, you should remember that the number of carbon atoms in nitrile and aldehyde are same. For example, if I have 1, 2, 3 carbon atoms and CN, in the first step, we are going from SnCl2 with H plus. That means in the presence of HCl. First step. Second step is H3O positive. So what we will get again? 3 carbon atoms and CHO. Okay. You can also use benzene nitride, that means benzene ring attached with CN. First, you have SnCl2 in the presence of HCl. Secondly, you can have H plus in the presence of H2O. You'll get the benzene ring as it is, and the CN will be converted to CHO. Got this? All of you, yes or no, please tell me. Please write the third one. अच्छा, एक चीज यहाँ पे लिख लीजिएगा. This is known as imine. ठीक है, इसको क्या बोलते हैं? This is known as imine. Right, next. Third one, using Debal H.
Sir, can you show the previous one?
Yeah, just a second.
Yeah, done. Sir. Done, sir.
Yes, yes. Using first of all, Debal H. So Debal H is a short form for di-isobutyl aluminium hydride. So di-isobutyl aluminium hydride, that means aluminium. Please see here, guys. Then you will write aluminium will obviously have one hydrogen, and then it has di-isobutyl. What is isobutyl? When you have carbon atoms like this, one carbon isobutyl. So here you have 1, 2, 3, 4 carbon atoms, and this particular arrangement is known as isobutyl. Iso arrangement of the butyl carbon. Okay, so this is the structure of Debal H. You पूछा नहीं जाएगा, but फिर भी आप लोग लिख लीजिए. You should know the reaction, what it is doing. So Debal H, it can convert both nitrile as well as esters into aldehyde. So you can have RCN, or if you have RCOO, that means you will have something like this. O and OR dash. पूरा लिख दे क्या? ऐसे लिख दीजिए. C double bond O and OR dash. You will treat both of these things with Debal H. Secondly, with water. Both of them are going to give you RC double bond O from RC will be from the what? Nitrile, and RC will be from the ester. Then there will be hydrogen here. Number of carbon atoms will not change. Okay, number of carbon atoms remain same. You will write it like this. Nitriles and esters can be reduced using Debal H. And on further hydrolysis, they form aldehyde. How much is done? Is that right? That is fourth one. Let me know if you are not written. Sabne likh liya? Anyone still writing?
Yes, sir.
Okay, please write. Let me know once you're done. Yeah, let me know once you're done.
Done, sir.
Yeah. Right, the fourth one, that is Etard reaction. Again, if it has got name, it is important. First of all, you will look at the reaction, then you are going to write the statement also. Okay, please see. We'll start with toluene. So you should know what is toluene also. No? Toluene is benzene ring with a CH3 group. This is toluene. Now, when toluene, it is treated with chromyl fluoride. Chromyl fluoride. Chromyl fluoride is CrO2, Cl2. When it is treated with chromyl fluoride in the presence of a non-polar solvent. Non-polar solvent, I'm writing CS2, carbon disulfide. It is not doing anything. It is not treating, it is not getting reacted. It is not a reagent. It is just a solvent. Non-polar solvent. It forms a brown chromium complex. The structure of brown chromium complex is not very important for you guys, but it should be present in your notes. Once writing in the notes, you will forget it. Okay. I'm not saying key. I'm not predicting the future that you will forget it. I'm asking you, after writing the structure, you forget the structure. Okay, no need to remember the structure. Use your memory and attention for something more beneficial. O CrCl2OH whole twice. CrCl2OH whole twice. This is brown chromium complex. When this is further hydrolyzed in the presence of acid, that means in H3O positive, it will give you aldehyde. So it will give you benzaldehyde to be specific. Okay, this reaction is Etard reaction. So what is happening here? Please write. When toluene reacts with chromyl chloride in non-polar solvent, it forms a chromium complex. It forms a chromium complex. And on further hydrolysis, it gives benzaldehyde. It gives benzaldehyde. Okay. Now, one more thing that I will ask you guys is to remember that we are having two steps here. So you can write both these steps in a single reaction. Okay, so how will you write it? Please see. So in the first step, CrO2, Cl2 in the presence of CS2, non-polar solvent. Second step is H3O plus. Okay. Same thing, you can write it like this. And what I have seen from the board's pattern and their way of checking paper is that the chemical reactions are more important than the statements. Okay. So if you have written the chemical reaction, then it will be given complete marks. But if you have written only statements, sometimes they will deduct marks. Okay. So statement is not very important. The reactions are more important. Right. Next, using chromic oxide. Using chromic oxide and acetic anhydride. So again, we will be using toluene. We will be reacting this with chromic oxide. Chromic oxide is very easy, CrO3. Acetic anhydride will be CH3, CO whole twice, oxygen. Acetic है ना, यही हो गया ना, एसिड हो गया. एसिड में आपने क्या कर दिया, एनहाइड्राइड बना दिया, बस हो गया. That's it, acetic anhydride. This will give you a benzylidene diacetate. अब इसको भी बस लिख के भूल जाना है. Benzylidene diacetate. क्या स्ट्रक्चर होता है? You will have CH, then you will have OCOCH3 whole twice. ठीक है. What is this? This is benzylidene. Benzylidene diacetate. Further hydrolysis, you will get benzaldehyde. Done, everyone? Is please tell me. Write the sixth one. By side chain chlorination. By side chain chlorination. Please see here, guys. This is a reaction which you can understand a bit because it is not involving any D block elements. Okay. So if you have D block metals, those chemical mechanisms are very difficult to understand. This you can a bit if you have done haloalkane, halorine, or an alcohol, both of these things. So first of all, I will react this with Cl2 in the presence of HNO. So what I am doing free radical halogenation here, and in free radical halogenation, some of the product that we will be getting will be carbon atom, hydrogen, and 2 chlorines. So chlorine has replaced 2 hydrogens. Right? Then what I will do, I will react this with H2O with heat around 100 degrees Celsius, that is 373 Kelvin. Now, when H2O is reacted with haloalkene, this is the carbon connected with chlorine, it is haloalkene. So what will happen when H2O is reacted with any haloalkene, the halogen group, it is replaced by OH. We'll have OH here. We'll have OH here. Then further, what is going to happen? Whenever we have digem-ol kind of situation, what is digem-ol? Digem-ol or gem-diol, it is when one single carbon, it is having two OH groups. Okay, please don't write, please see here guys. When a single carbon atom, it has two OH group, it is known as gem-diol. And in this case, I have done this in the first class of the alcohol chapter. Water is released. Water will be broken off like this, and you will be forming aldehyde. तो जब यहाँ से H2O निकल जाएगा, what you will be getting? The benzene as it is, the carbon as it is, with the hydrogen as it is. And when the one oxygen and two hydrogens are left, we'll get only one oxygen remaining, that is CH. This is again from toluene to benzaldehyde. Now the last reaction, it is very important because it is a name reaction. Seventh one, please write. Gattermann-Koch reaction. If you want to mark it like this, now you can mark it like this. Minus H2O. Now, in Gattermann-Koch reaction, what happens? Please see. So start with a benzene ring. We'll give it CO. KO से याद रखिए, you will get CO in the presence of HCl. है ना? So see here. All of you have seen gutter. हाँ, ना बताएं. You have seen manholes, right? Manholes. The cover of manhole, it looks like something like benzene, yes or no? अरे manhole का cover जो होता है, ऐसी तो होता है. You don't know what is manhole. रजिता, फिया, सफिया, माजिद, नहीं पता. गटर पता है? गटर. गटर पता है? गटर पता है? गटर का ढक्कन देखा आप लोगों ने? ऐसे ही होता है ना, बेंजीन जैसा होता है. हाँ सफिया.
यस सर.
है ना? तो गैटर से वो याद रहेगा. गैटरमैन से you will remember that we have what गटर वाला. KO से you will remember CO. और HCl कहां से? HC यहाँ पे दिख रहा है. You can see HC. HCl यहाँ से याद कीजिएगा. गैटरमैन बिल्कुल आसानी से याद हो जाएगा. ठीक है ना? गैटरमैन because here we are having three different reagents ना, that is why it is difficult. So गैटरमैन में you are going to have benzene, CO and HCl in the presence of anhydrous AlCl3. अब इसको आप अगर एग्जाम में नहीं भी लिखेंगे तो ज्यादा मार्क्स आपके कटेंगे नहीं, मार्क्स आपको मिल जाएगा. Important things are these three reagents, but you also try to remember anhydrous AlCl. What is going to happen? You will get benzene and aldehyde group, that is CHO. Okay guys, so from benzene to benzaldehyde. If you want to write the statement, you can write the statement here na, ऐसे, when benzene is treated with carbon monoxide and HCl in presence of anhydrous AlCl3, it forms benzaldehyde. यहाँ तक clear है guys? Yes or no? Please tell me. Is everything clear till here? Yes or no?
यस सर.
Yes, sir.
ठीक है. So here guys, the complete method of preparation of aldehyde is over. There are 7 methods of preparation for the aldehydes. ठीक है, देखिए ध्यान से. So you have to remember all of these. It's not that one is important, the other is not important. Each and every one is important. Okay, so you have to remember all of these. And in all of the cases, if you see here, it starts with toluene benzaldehyde in side chain, in chromic oxide. Also, in the case of the ETAR reactions, the same thing is happening. Only the reagents are changing. So not much difficulty. Debal is, you have to remember, nitrile and ethyl. Then in Stephen reaction, you can remember that it is nitrile, and then you have the Rosenman reduction, in which you are going to have catalytic hydrogenation in the presence of palladium and barium sulfate, right? So these are the 7 method of preparation for the aldehydes. In the next class, we'll be looking at the remaining 2. That means we will be looking at the MOP of ketones, and we'll be also looking at the MOP of aldehyde and ketones both. ठीक है, इन दोनों को we will be doing in the next class. All of these reactions are very important. अभी इसको revise कर लीजिए please guys, all of you. Please start revising from this part, Rosenman reduction and all of these things. You have to remember each and every part here. Okay, Rosenman reduction. What is the substrate? Substrate means the organic part of the reactant. ठीक है, एक चीज हम, there are some new students, that is why I will let you guys know. In each and every reactions, we have substrate, we have reagent, and then we have the product. So what is the substrate? Substrate is the organic part of the reactant. Reagent is the most reactive part. Most reactive part. Okay. So for example, if I go to the first reaction here. So acid chloride it is the substrate. H2 it is what? It is the reagent, and PTBSO4 it is a catalyst. है ना? अब ये थोड़ा सा अलग केस आ गया, catalyst आ गया आपके पास. But you will always have substrate and reagent, which will give you product. Next, in the other case, you can see what is the substrate here. Nitrile is your substrate. SnCl2 and HCl, these are the reagents. Both of these are what? Both of these are reagents. So you have to remember all the 3 things. अब इसी में जानते क्या काम आएगा? Please see here guys. You will make, when you are going to make a chart of name reaction, ना, you will write name reactions like this. अब इसको ऐसे ही बता देते हैं अच्छे तरीके से. देखिए, you have to make a chart of name reaction for complete organic chemistry. You will start like this. Name reaction आपने लिखा है ऐसे. Name reactions. ठीक है. Number 1 name reaction that you are going to get is for haloalkane halorine. Now in this, इसको number 1 मत दीजिए, फिर इसको ऐसे कर दीजिए, haloalkane halorine. In this first you will see Sandmeyer reaction. ठीक है. Please see here guys, this is how you are going to make the chart. You are going to make the list of name reaction. Will you write the Sandmeyer reaction? No, you will not write the Sandmeyer reaction. In bracket you will write MOP. क्या मतलब MOP का? It is present in method of preparation. Now what it is serving here is that as soon as you write method of preparation, आपको पता है कि आपको क्या मिलने वाला है यहाँ पे. You are going to get some RX kind of thing. Sandmeyer reaction में आप या तो ऐसे कैसे method of preparation of haloarine. ठीक है. So method of preparation of haloarine में आपको क्या मिलेगा? Benzene ring with X. At least you know this much. For example, दूसरे एग्जाम्पल हम देते हैं आपको. Let us suppose in alcohol chapter में इसी को देख लीजिए. In aldehyde ketone carboxylic acid, you have a reaction. We just saw Rosenman. So MOP of aldehyde. So you know that product में क्या आने वाला है? RCHO आने वाला. You don't have to remember now, na? As soon as you have written MOP of aldehyde, you don't have to remember ki what is the product. So when you will make the complete sequence, na, name reactions, haloalkane halorine. So whatever name reaction is in the method of preparation, you will write those things. You already know that what is the product. You have to remember only 2 things now: the substrate and the reagent. So थोड़ा आपका काम आसान होगा. If you are remembering, if you are learning the name reaction, do it by chapter wise and also MOP and chemical properties. And let me remember some chemical properties. Yeah, let us suppose you have in alcohol. In alcohol, you have a test that we call Lucas test. Okay, and Lucas test will be in chemical properties, so you will write Cp of alcohol. Now, as soon as you have written chemical properties of alcohol, that means the reaction will start like this: ROH plus something will give something. So now here also what is done? We have remembered one thing. What is the substrate? You know it. What is the reagent? You don't know. What is the product? You don't. So if you are going to remember it in this particular order, if you, for example, Lucas test, if they are asking, then you will remember, okay, fine, it is in alcohol for sure. If you will write the chart in that manner, then you will remember it's in alcohol and it is in the chemical properties of alcohol. So आपको ये पता होगा कि at least we have to start from ROH. और धीरे धीरे ही तो लिंक बनता है ना, कुछ चीज याद आती है, फिर कुछ चीज याद आती है. थोड़ा सोचिए, when you were in 9th-10th standard, you used to do congruency problems, right? You used to do similarity of triangles problem, right? What you used to do then? जो एंगल इक्वल आता है उसको इक्वल निकाल लेते हैं ना. फॉर एग्जांपल इफ आई हैव पैरेलल लाइंस लाइक दिस और ऐसे है, तो आपको ये एंगल निकालना है. बट आपको दिया हुआ, मान लीजिए, या दे हैव गिवन यू व्हाट, सपोज दे हैव गिवन यू दिस एंगल, दिस इज 80 डिग्री. ठीक है, तो व्हाट इज दिस एक्स एंगल? तो आप एक्स एंगल की तरफ ध्यान लेके नहीं जाइएगा. पहले क्या कीजिएगा, जो एंगल निकल रहा निकाल दीजिएगा. एक्स एंगल 80 दिया हुआ है, हम इसको निकाल लेंगे. दिस विल बी हाउ मच? 120. दिस विल बी हाउ मच? 120, बिकॉज़ वर्टिकली अपोजिट एंगल, और ये इंटीरियर अल्टरनेट इंटीरियर एंगल. तो थोड़ी थोड़ी चीजों से आगे की चीज निकलेगी. इफ यू रिमेंबर what is substrate, then the chances and the probability is higher that you will remember the reagent and the product also. So whenever you are doing this, आप इसी सीक्वेंस में कीजिएगा. those who are new ना, उन लोगों के तो बहुत जरूरी है कि वो चैप्टर्स जो है पुराने, उनका रिकॉर्डिंग जरूर देखें. ठीक है, बिकॉज इन each and every chapter I have asked these guys to, for example, alcohol कहाँ खत्म हुआ था, physical properties, हाँ सी, MOP of alcohol, you have to make charts. ठीक है, इसके बारे में हमने बताया था that you will have to make charts for method of preparation of alcohols. उसी तरह से chemical properties of alcohol. ठीक है, तो पुराने लेक्चर्स जरूर देखिए आप लोग, you will understand how to do organic chemistry. ठीक है, खैर वो सारी चीजें बाद में आएंगी धीरे धीरे. आज के लिए इतना ही है. इन द app, Learnivio app, है ना, I hope all of you guys have Learnivio app. In Learnivio app, if you open it now, you will see a assessment, ASSE. assessment का स्पेलिंग शायद ऐसे होता है, ASESSMENT. okay, or it is either like this, ASSESMENT. ठीक है, एक में डबल एस होता है, एक में सिंगल एस होता है. So there will be assessment. Go to that assessment, you will see method of preparation of carbonyl compounds part 1, ऐसे करके होगा, या it will be MOP of carbonyl compounds part 1. Please go to the Learnivio app, you will see a test. ये कैसे था जरा.